which of the following names is correct for this structure? So we're looking at a disaccharide over here, right? So this would be a disaccharide over here. And feel free to try this question out. But what I would suggest for the first step is to count the number of carbons. And in order to know which carbon we start with, we usually start with the anomeric carbon. So on both sugars here, we want to identify what the anomeric carbon is, right? So we know that anomeric carbon is next to this oxygen for both carbons, for both sugars. So it's either this one or this one. So what do we think? Is it this one or this one? Well, we can see that this carbon here, it's actually before this anomeric linkage is formed, before this link is formed, this carbon is attached to this oxygen, which is a hydroxyl group before the linkage is formed. So we know this carbon is not an anomeric carbon. The anomeric carbon is this one, right? So before it's joined, it's actually just a carbonyl group like that, right? So this is the anomeric carbon. So likewise here, this one is anomeric carbon. So now we can number. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So now that we number the carbons, we want to identify what sugar is it by looking at the orientation of those hydroxyl groups. So first, both sugars have 6 carbons. And second, both sugars, carbon number 3 is pointing up. And all the other carbons, carbon number 3, the hydroxyl group is pointing up. And now all the other carbons, 2 and 4, the hydroxyl group is pointing down. Right, so we have up, down, down, up, down, down. And because of this, we know that it's going to be a glucose. And on an exam, if you see options like those on the right, every option says that it's going to be a glucose. So it's actually not necessary to identify the sugar, but it's always good practice. So here, we know that both sugars are going to be glucose, right? So glucose there, glucose here. And what do we think the second step is? Well, if we look at the answer choices, we can see that they have alpha, beta, alpha, beta. So those are actually the designation for the anomeric carbon configuration. So the only anomeric carbon that we're interested in, what do we think? Do we think, are we interested in this one or are we interested in this one? Well, obviously, we're more interested in this one. And why? Because this one is involved in the linkage of the disaccharide, right? So that one is the most interesting. So if we look over here, we can see that the hydroxyl group on this anomeric carbon is pointing down. And this thing over here, this linkage between carbon number 5 and 6, that's pointing up. So because they're pointing in different direction, so different direction, we know that it's going to be a alpha carbon. So it's going to be alpha carbon. And because it's alpha and this one is carbon number 1, so we know it's going to be alpha 1. So because of that, we can now eliminate some answer choices. We can eliminate answer number E, which says beta. We can also eliminate answer number B, which says beta 2. So now, and also we can also eliminate answer number A, right? Because we know that on the second glucose, the carbon involved in the linkage, in the disaccharide linkage, is not an anomeric carbon. So this one suggests that that's an anomeric carbon, but this is not anomeric, right? And what we're interested in here is actually just the numbers on this carbon that's involved in this linkage. And this carbon is number 6. And now we have our answer. So the answer is going to be You got it right. So the answer is going to be option number C, right? We have alpha 1 to 6. So, and we have both sugar as glucose. So that's it for this question. Thanks for watching.